Good afternoon, everyone. Welcome back from lunch. We've covered a lot of ground today. We've already talked about digital factories, design and make, manufacturing capacity, competitiveness, ecosystems, energy, IoT, AI, and we've just barely finished lunch. So I was thinking about this, if you're playing kind of a buzzword bingo, I think we only have a couple of words left. Future of manufacturing, public-private partnership, although I think I heard Liz mention that earlier. And those topics are coming up shortly. But there's a reason these topics are coming at us so fast and furiously. In a world that changes rapidly, ever-changing world, the amount and the pace of change that we've experienced in the last 3+ years has been unprecedented. We're coming out of the global pandemic, supply chains are shifting, geopolitical tensions are on the rise. We still see skilled labor shortages, as you've heard about. Meanwhile, products continue to get smarter. And as an example, with the electrification of vehicles, we're going through a once-in-a-100-year change in the automotive sector. Just as one example. All the while, technology continues to race ahead. And with that, opportunity races ahead, but also trepidation. So who wins in this environment? Well, Autodesk's recent State of the Design and Make Industry report found that those companies who recognize that change is constant, who embrace it, and those who consider themselves digitally mature, at least in a relative sense, they've outperformed their competition. Why? Because they proactively seek out ways that technology and data can help them to become more agile, more efficient, and more competitive. Now, speaking of winners in this environment, I have a few on stage here with me. And I'm looking forward to having them share some of their experiences, some of their approaches to planning, building, and operating a digital factory, and how that's helped them and their customers to win. So please welcome Tom Raun, Chief Technology Officer at Iscar. Tom has the highest certification in Lean and Six Sigma methodology for process improvement. He oversees a team of specialists who develop and articulate cutting tool application strategies that drive machining process improvements. Next, Dan Middleton, Head of Innovation at Edwards Vacuum, part of Atlas Copco. As Head of Innovation, Dan is charged with automating Edwards facilities. He drives a strategy for both the physical and digital automation that's coming to life in their digital factories, and he's got a few new ones on the way that he can tell us about. And finally, Dr. Tilman Buchner, the global leader of the Innovation Center for Operations within BCG. Tilman is an expert in the industrial metaverse and the Internet of Things ecosystem, as well as a recognized thought leader in software-defined automation and cognitive robotics. Gentlemen, thank you for being here.
Thanks for having us.
Let's dive right in. All right, each of you have embraced digital factories. Let's start out by talking about your respective journeys. Like, how did you start? How did your company start? And where do you find yourself today? Tom, you want to start us off?
Yeah, so being employed with Iscar for just over 20 years, I was exposed to a high level of automation very quickly. Just real quick, for those of you who might not know, Iscar, we're a cutting tool supplier. Cutting tools are a manufacturing technology that wear out very quickly. So we're shipping and producing millions upon millions of items a year. And it becomes very important to have a high level of automation to do that quickly, accurately, and to do it at a price point that's met by the needs of the market. And so in that endeavor, I was exposed to high level automation early, but over the years, I've seen what I would envision a digital transformation kind of in two areas, internally and externally. So internally, the company is always embracing nascent or modern technologies that help the process of creating cutting tools improve. And so I've seen, kind of the digital transformation for us from even a high level of automation is interconnecting factories that are in different countries maybe, and using the data that we're gathering from those manufacturing environments and sharing and improving in that way. But for me and our activities with our end users, the external journey is providing the cutting tool data to our customers, whether it's via electronic catalogs and not just models of our product, but also the cutting tool parameters that go along with it. And so to meet those needs of the customers, that's kind of the digital journey that we're on. And to go back to Iscar and our manufacturing environment, one of the things that I think led me to sitting here in this chair was we had some Autodesk representatives come over and visit our factory in Israel where Iscar was formed, and they were impressed by the high level of automation we had, and that was saying a lot coming from Autodesk, who knows automation. And so what I can say there is that all these millions of inserts, carbide inserts and carbide cutting tools, they go through production processes and they're never touched by human hands until the day it's opened up by the end user that purchased that cutting tool. So it's something we take pride in. It helps our company function at a high level, and to be able to continue to improve upon that's going to be important for the future of our company.
I'm going to hear more about your automation success in a little bit. But Tilman, why don't you tell us? What are you hearing from your clients?
Yeah, maybe from my clients, and maybe also let me share my personal journey on the digital factory, right? So I think it was 15 years ago when I started dealing with the digital factory, mostly building MES systems for clients. At this time, it was very much about dealing with a tool chain, for example, from Siemens, with Technomatics and others. At this time, there was no cloud. There was no connectivity into the physical world. There was no edge computing. And I think the first visualization systems we built with very simple solutions. And now if we compare this as of today, as we've also heard in the previous talk, now there is cloud computing, there is virtualization technology, there are industrial edge devices. Now we can gain data out of the shop floor. And I think we could claim also today that I think we can close the simulation to reality gap, and turn the idea and the vision of a digital factory really into reality. Now, if you're asking me how clients actually think about this, I think we need to, technically speaking, it is feasible, but only because it's technically feasible, there's no reason why really people adapt to it. So we also need to work on actually the customer demand, which is asking for such solutions. And I think there's one interesting observation which we see at many clients, and this is in the area of sustainable engineering. So all companies in production environments, they need to strive for reducing their CO2 emissions. If you think of 80% of CO2 emissions occurs in scope 3, which means along the supply chain. If you really want to change this, you need to start rethinking in engineering. Because in engineering, you have the degree of freedom to change something. If you do product design, in the product design phase, you can decide if your product at the end can be recycled, can be repaired. Yeah? But to do this, you need to bridge your application boundaries. And this is, I think, where we need to head to, and where the digital factory can really help and be an enabler to do this.
Great. Dan.
So we're going through a massive, in the semiconductor industry, it's going to be a once-in-a-lifetime boom. So $1 trillion spent in the next 10 years. So we've got to be ready to support our customers in scaling for that. So we don't have the luxury of time to scale. So what we've got to be able to do is have our factories modeled, set out, and delivered. Typically at the moment, it takes us about 2 years to set up a facility and get it operational. our drive through what we've achieved through some of our other factories in achieving the digital twin, we're down to now 18 months. Our drive now is to get down to 12. So that's why we are doing it. We're really fortunate that we have a facility out in Antwerp where all of our partners and all of our companies within the Atlas Copco group can go there and then go play. We can fail fast, we can understand what does work, what doesn't work, and effectively we now pretty much understand the cooking ingredients we need for a digital factory.
I remember when you and I spoke earlier, I was impressed that you have basically a sandbox to play. It's almost it's a prototype of a factory,
yes,
in a sense,
yes.
Outside of Antwerp, which I think is brilliant. Oh, well, also, you're building 5 new factories. Am I remembering that correctly?
5 new factories, 5 years. Yeah.
Is 5 new factories in 5 years? Now, first off, what's driving that? Is it a demand? Is it you need to keep up with the competition? You want to extend your lead on the competition?
It's multifaceted, Jeff. So for us, there's the geopolitical issues that we have. So you look at United States and China, so locking each other out of the semiconductor businesses. China has a drive to be 85% self-sufficient in chip manufacturing. And then you have Europe, US, and Japan now locking their technology down so it can't go into China. So that's the geopolitical angle of that. There's the reshoring then, so we have to then reshore our operations. What COVID taught us is our infrastructure is quite weak. So we now have to strengthen that by reshoring our operations. And then giving us a competitive advantage over our competition as well. So we have a lot of third parties that try and come and eat our lunch, and we've just got to stay ahead of them and make sure that we can do things faster, we can do things cheaper, but not sacrifice any of our quality.
That's great. We talked or heard a lot about data and the importance of data. As each of you look at your own manufacturing processes and those of clients with whom you work, what role? I mean, how are you employing data? What role is data playing? Is it actually are we realizing the full potential? How important is it to have, are you finding it to have that connected data flow from engineering all the way down to the shop floor? Actually, I'll start, Tom. You've got a lot of shop floor experience.
So the cutting tool industry's idea or approach to creating that connected shop or data flow throughout from engineering down to the shop floor, it started over a decade ago with ISO 13399. And ISO 13399 has some pros and cons. I'll start off with the cons and then finish with the good stuff. So the cons, it's heavy. It's a heavy amount of data, a lot of definitions, maybe hundreds of definitions for each item in a cutting tool assembly. And what we quickly learned was that the mistake was that there was a lot of cutting tool companies involved in creating the ISO standard, but they didn't involve the CAM companies in that endeavor, because what we've found recently is that it's a lot of information to digest. It really is, it's overkill, and so there's a lot of information there that doesn't get consumed. Now, the pros to the 13399 is that now what used to take an engineer pulling in individual items and then putting them together basically happens automatically. A lot of the cutting tool companies' websites, you have the ability to create an assembly right there. Now, not everything is there, but most of it is there now. And so with that, there's opportunities to improve processes, to quickly program processes, to verify in a digital world and make sure that there's no collisions or any damage that's going to happen to equipment. And as the CAM companies, like right now, another reason why I'm sitting here, we're working with Autodesk in their Fusion environment to try to create a more interconnected architecture, so to speak, where the cutting tool, not only the model, but the data, the cutting parameters that go along with it, it's a click of a button away instead of a whole lot of manual data entry, which it creates opportunities for errors in scrap parts or damaged equipment. And so, that's the importance of it. And we're still working out the details and getting to where manufacturing technology suppliers like us are talking to one another and figuring out ways to leverage it and provide it to end users. And I think that in the very near future, it's going to be a brighter picture for everyone who's programming.
Yeah.
Great.
And you pick up on a valuable point there, Tom. And that's something that we learned, is that we basically architecture everything in one system. So we leverage the power of Fusion, and we put that straight into Pro model then. That then allows us then to go from a 2D model all the way to a 3D model to a simulation model, all the way down then to our CAD CAM, then for using Power Mill, Power Inspect. So everything is there. So no longer removing bits of information in and out of different systems, and that was our biggest learning there. So you've heard a lot of it today in a lot of other people's talks. Trying to move bits of data in and out of different systems is fraught with danger. You're going to lose little bits, traceability is going to go all over the place. So that's the biggest learning that we took, and therefore we said, right, okay, we want to work with a partner who has the capability to be able to do all of this, but also then a partner has the vision of where are they actually going with it at the same time as well. So that's really important to us. So the construction cloud is a big thing that we're going to start leveraging. And the reason for that is because our team is global, and I now have an engineer that is in America, an engineer in the UK, and an engineer in Korea, and they can work on the same model pretty much whenever they want to, at the same time if they so wish. I don't encourage it with the time difference, but if they so wish, but they can see the changes that have happened then as well. So no longer is because I've done this change, send an email, and you just lose traceability. So all of that just goes out the window. And life is much, much simpler.
Well, I think, yes, we love to talk about data, but what we see also at client sides is that, especially at start of production, there is no data. And this brings me to the point, I think it's of highly importance to actually bridge the design world with the shop floor and the manufacturing operations world, but only if we can really create value out of it. But let me give you an example. What we showcased together, right, at Hannover Technology Trade Show, and also you could demo this and see this at the left corner over there, is at start of production, you lack training data. So whenever you would like to identify, for example, quality defects, the idea that you just take a camera and machine vision and identify the defect doesn't work, because you don't have the training data. So if you connect and leverage the design data, which nevertheless they exist in your design phases, and you use new technologies like synthetic data generation and photorealistic rendering, you can generate needed training data sets in simulation, train your inferring models, and then deploy your pre-trained machine learning model into the reality and identify a quality defect. This is a great example where you really create new value when you ensure to have this end-to-end connectivity from the product design and factory design world into the shop floor world. And I think we need to look for more of these use cases to really find good arguments to also do this investment. Because at the end, yes, it is an investment into infrastructure to build these data bridges across application domains.
You know, you're talking about connecting design and make data, which is something that we're certainly passionate about at Autodesk. And you're already you're leading me to the next follow-up question I wanted to ask, which is once you start to connect that data, that begins to unlock so much more, right? So many more other either technologies or capabilities that can be brought to bear. Let's help us go beyond the data and connected data to what does that unlock, whether it's industrial metaverse.
Yeah, absolutely. What we think of are three aspects, right? I think point number one, which is more or less, let's say, achieved or completed, is like digitalization. Digitalization, also a reference to Industry 4.0. I think this was this entire, let's say, age about establishing connectivity into the physical world. This is where edge computing plays a major role. The next thing which we see is also containerization. Containerization means that we leverage and apply, let's say, the enhancements and operating model which we know from the IT world now into the OT world. We call this like applying a data center operating model for the shop floor. Because container technology, as we use in the IT world, can help you to better utilize your industrial control performance. And this can be done with soft PLCs, because nowadays we can turn classical hardware automation into software-defined automation components, which at the end is only software. And then we can deploy a PLC or an NC in terms of software into a container, which can run on an industrial edge device. And third, beyond digitalization and containerization, this is what we also previously mentioned, virtualization. So the enhancements in photorealistic rendering and synthetic data generation. And this, by the way, is actually powered by the NVIDIA H100, the Hopper 100 chipset, which also powers this whole ChatGPT and generative AI topic, which is very popular at the moment. But this is also the underlying kind of superpower which helps us to create these photorealistic renderings, which closes the simulation to reality gap, so that we can render digital factories which have the appealing as factories look like in reality. And we need this for the previously mentioned use cases if we want to create training data sets in simulation. So these, for sure there's also more, but I think these are three key technologies helping us to reach the next level of automation.
It's interesting. You think about your third one, virtualization, and how the possibilities that opens up in how you plan, build and operate a factory, right? Which is a good segue to both Dan and Tom. How are you today connecting the plan, build, and operate aspects of a digital factory? Dan, you're starting to build new factories. How are you connecting those? Are you using the tools or principles that Tilman is espousing, like digital twins, factory simulation?
Yeah, so really good question. So over the course of semiconductor service, for example, which has been around since 1981, we've got a lot of data around how our processes and how our factories operate today. You can never simulate every single eventuality. It's just impossible because you never know what's gonna come and what you're gonna encounter. But what we're able actually to go do is say, okay, we have our data from our manufacturing execution system, we have our data from our PLM, we have data from our HR systems. You pull all of that together, and other systems, and you pull all that together, and you say, right, how do I want my processes to operate? The processes I have today, are they actually fit for purpose? Do I want to continue copy pasting from one facility to another facility? Do I want to start challenging myself a little bit more? How do you start to drive those inefficiencies out? How do you start to bring in robotics, and where does robotics really help you in those? How do you start to automate other different processes within the factory that you can actually get to? I mean, a really good example here is a general manager will always be able to tell you why they've had a bad day, then can never tell you why they've had a good day. So with a digital factory, you'll have that recipe of why. All those answers will be available. So yeah, we use a whole host of tools. Like I said, we want to build them all on the same platform. We're a cloud-first organization. So if it can't be on cloud, we tend to ask the question, why not? That's what we drive for. But what we effectively do is we simulate our factory first without even building the walls. So we've simulated all that. Where does everything need to go? Then we start to then use things like Revit, for example, and BIM. And how do we then build our factory around that then as well? Because we have a drive for sustainability, so carbon neutral by 2035, which is a bit of a challenge, which is 15 years ahead of the Paris Agreement. This is what digital factory simulation will be able to give to you as well.
That's great. Tom?
Well, obviously, with it being a cutting tool industry that I focus on, I don't do too much planning or building of the actual building, but I can tell you I've seen the if you want to call it the horror stories of when a machine doesn't fit in a building or when something doesn't go as planned because there wasn't that planning. So I being here today and seeing some of the things that Autodesk is doing with that aspect of creating a factory is amazing to me. But getting into the operating and what goes on machines inside and machining cells in a company, you know, our goal is to drive continuous improvement for our customers and productivity. And we realize the digital tools, the digital twins of cutting tool models they're a part of creating that machining environment that can be, you know, viewed virtually and simulated virtually before it ever gets to the actual manufacturing of the part. And we're also, as I previously mentioned, looking at tools that, like what we call a tooling advisor or Iscar tool advisor, where you provide the cutting operating parameters of the data with the tools. And that's kind of the holy grail for the cutting tool aspect, because right now a lot of people can go and extract models and get that model, but then it's okay, how do you run that tool? How do you run it in this material on this machine with the constraints that you have? So one of the areas we're working on is obviously collaborating with Fusion and Autodesk to make that click of a button that takes data that we know about our tools, that it can operate in a certain way in a given situation, a given material, and on a given machine, and to be able to create kind of an expert output for a layman who might not have that experience, you know, like we have in a given material or situation.
Yeah. You know, it was interesting this morning, I was surprised at how few people raise their hand and whether they're using digital twins or not. You know, when Andrew asked that question, and I think we have to realize the opportunity. I think we have a lot of work to do, and like Tilman, like you said, we have to show the value, show how that demonstrates value and creates value.
Yeah, absolutely. And I think when it comes to digital twin and simulation, if I need to explain this to my grandmother, what simulation is in digital factories, I always try to come up with a comparison of, and I think maybe you also experience this, when I go for a run, I start dreaming and thinking. Yeah? Maybe you also, I've written, I don't know, hundreds of emails, but never sent out one of them after the run. And this is a little bit like what the value of simulation is. Simulation means that you are capable to come up with hypotheses, and you try to simulate and run through different versions of it. And for me, the difference also between a digital twin and the industrial metaverse is the digital twin is like a digital replica maybe of a certain process, of one instance. But what you can do with the industrial metaverse, you could use different simulations out of different domains, like an FEM, finite element methodology, or a computer-free dynamic model, or another simulation. And there is one common data model, one common view. And in the industrial metaverse, you can actually have a shared perspective across these different simulations, and you can run through hundreds of thousands of different variances of this. And you need to think of this. This also needs to be managed. And this is what the industrial metaverse is helping you. It manages actually your dreaming processes. You can run through alternatives. And I think we need to understand this value and these new capabilities, because all of this is only possible because of the power of the cloud. The power of the cloud enabled this. And the more we understand this, I think the more we could also use this in reality.
And AI, right? I mean, it's funny, if you said the industrial metaverse helps you dream, I feel like AI gives you more REM cycles to to accelerate your dreams.
Absolutely, yeah. And this is also where this whole topic of generative AI also now comes into play. Yeah? The only caveat on the whole side is like, there's also a little bit of a downside, and this is because in the manufacturing world, we live in the real world. And in the real world, we have complexity. But the difficulty is that our AI systems, there's no reasoning, because we lack a causal model of the real world. Think of robotic applications. There is no situational understanding of a robotic system. If you look to a welding robot and you ask this robot, what are you doing? The robot would answer, I don't know. Yeah? But we need to work on building this muscle and need to do a higher investment, not only in dealing with data and investing into AI, but also invest into modeling the real world.
Right. Which we'll need for autonomous vehicles and many of those other applications, right?
Exactly, and that's the same as we see in autonomous driving. Yeah? I think if we strive for level 5 autonomous factories, as we strive for level 5 autonomous driving, I think for some areas we even achieve it today. Yeah? But if you try to go with a self-driving car into the city center of Boston, maybe you run into a problem. And that's the same as in factories. And even in a factory environment, it could be even more complex than the real world in a city center.
My God, modeling the system for autonomous driving in Boston sounds incredibly daunting. All right, last question, because we're coming down to the end. We've seen a tipping point in how automotive OEMs are embracing the future of electric vehicles. I think Toyota was the last domino to fall. And so we've seen that in the electrification of vehicles. With all the factors we've discussed today around manufacturing, connected data, automation, IoT, AI, digital twins, is there a tipping point, a similar tipping point for digital factories? Are we there now? Is it, if not now, when will it happen? I'd love to hear each of your kind of rapid fire perspective on that.
I can go first. So I think we are there now because no organization now can just go build a factory and leave it empty. It's just not sound business sense. But equally, no organization can think about, okay, I'm going to take the next 5 years to be able to figure it all out. So the technology is here. It's now the will of wanting to go do it. I think there's we talk about digitalization. It's not a top down. It's not a bottom up. It has to be both. And if you have that in your organization, you're pretty much already there. You've got the will to actually go and do this. The technology is already there. It's all now just linking it to your strategy and what's the value that you're going to get out of it. Because if you get no value out of it, there's absolutely no point doing it. But we see a huge benefit in doing it, which is the reason why we're heavily invested in it.
Tom?
I think it depends on the industry and size of company, which is probably an obvious answer for a lot of us here. But in manufacturing, we deal with a lot of small and medium-sized companies that, there's signs of life there too, because we're seeing people that have a building and they put a machine in and they use AI and automation to be able to run the machine when they're at their day job or they run it on the weekends or at night. And I'm starting to hear rumblings of things like that. So I think with AI and as the technology continues to accelerate like it is, I do believe the tipping point will come soon. Maybe I'm hoping after 10 years or so when I retire, but no, I think it's going to be a fun ride here over the next decade, and large companies are already incorporating it, and it's going to have a big impact on manufacturing. And as long as we can fill the pipeline with skilled individuals, which is another key area, and this is an area that AI will hopefully help us with, but we're still going to need qualified people that know the technologies and can help manufacturing go to this next level. So if I had to say a tipping point, I'd say maybe 2030 in general.
Tilman?
Yeah, I think as always in life, it depends. I think not every factory will turn into a dark factory. As said previously, for sure for some of the manufacturing processes, even today we can build in resilience and build in self-adapting processes. That's doable with all the technology you referenced. But nevertheless, I think, but we see this also in science. Science is also now investing into modeling approaches. We also see this on the capital market, that some of the companies which have been acquired by big tech giants in the past time is focusing on building models of the real world for certain domains and verticals. Yeah? And I think the entire warehouse and logistics business, for example, will be one of the first markets or models which we will see.
I concur, and not that anybody asked, but my feeling is it's kind of a combination of all that you're saying. I think we are there. I think we are there right now. I think it's going to be more of a tipping arc than a tipping point. Partly because we're talking about multiple industries, right? It's not, and automotive, you think about there's obvious manufacturing benefits in terms of reduced complexity on an electric vehicle, but it's also hugely demand driven. Like suddenly it was very demand driven. And I think as we look across all of our industries, that demand will be a longer, maybe a longer process. So I'm not sure you'll actually see a point. AI may accelerate, may make the arc a little bit steeper, but I do think we're in the midst of it right now. And that's all we have. Thank you, everyone.
Hey, look at that.
Thank you,
Right on
panelists.
time.
Thank you.